Hi everyone, in this tutorial I'm going to solve the past paper questions related to the quadratics or the quadratic equations. We consider the quadratic equations as ax squared plus bx plus c equals to 0. This represents the general formula for the quadratic equations. Therefore, if we have an equation in this form, 3x squared minus 4x plus 7 equals to 0, you can say that x raised to the second power, therefore it represents a quadratic equation. From this definition, you can notice that it's not possible for the a coefficient to be 0. In this example, the a coefficient is 3, and we call this a coefficient the leading coefficient. Therefore, here we can say that the leading coefficient equals to 3. As long as the leading coefficient is positive, it's above 0, then when we want to sketch the curve for this equation, then we are getting this form for the curve of the quadratic equation, which is a concave up curve. Therefore, you can say that if we get this concave up curve, it means the leading coefficient is larger than 0, it's positive. We can notice that there is a vertex here which represents the minimum point for the function. And if the leading coefficient is negative, for example, if we have the quadratic equation negative 3x squared minus 4x plus 7 equals to 0, you see that here the leading coefficient is negative. That means a is negative 3, or you can say that a is less than 0. It's below 0, that's why it's negative. When it's below 0, and we want to sketch the curve for this quadratic equation, then we get a concave down shape. And in this situation, the vertex here represents the maximum point for the curve, or the maximum point for the function. Another important thing to remember is how to get the coordinates of the minimum and the maximum point of the functions. We need to apply a specific formula in that case, which is called the vertex form or the vertex formula. The vertex form is like this: the leading coefficient multiplied by x minus h all squared then plus k. When we are changing the quadratic equation to this form, then we can directly get the h and k values. So h represents the x coordinate and k represents the y coordinate of the maximum and minimum points. Okay, the next important thing to remember is that how we solve the quadratic equations. So solving quadratic equations can be carried out through 3 different methods. The first method, we call it completing the square. Completing the square is in this form. It's exactly the same as the vertex form. That means we try to change the quadratic equation to this form: a times x minus h all squared plus k. So this h and k can take any symbol. Okay, the second method is called factorization method or factoring method. And the last one is by using quadratic formula. The quadratic formula is like this. We want to get the values for the x in the quadratic equation or solving for x. It can be achieved by the application of this formula, which is minus b plus minus the square root of b squared minus 4ac all divided by 2a. If you look at the quadratic equation here, you see that we have a coefficient, which is negative 3, and the b coefficient is negative 4, and c coefficient is 7. Therefore, we have all b, a, c coefficients. We can directly apply them here in this formula to get the values for the x, which represent the solution for the quadratic equation. One more important thing is, what does it mean by the solution of quadratic equation? We can actually draw the x-axis coordinate, and whenever we are sketching a quadratic function, it can be concave up or it can be concave down. Then in math, when we consider the solution for quadratic equation, that means we try to get the x-intercepts that the curve makes with the x-axis. Therefore, all these points represent the solution for the quadratic equation. That means when we consider the solution of any equation, it's the same as we are getting the x-intercept. So the x-intercept represents the solution and even represents the roots of the function and also represents the zeros of the function. Therefore, we can actually use different terms. If we are looking at these two curves, you see that we have two intercept points on the x-axis. That means we have two solutions for the quadratic equation that given here as an example. However, in some situations, we may have no any solution for the quadratic equation. And that's the case if the curve sketch locates below the x-axis or it can be above the x-axis. That means there is no any x-intercept. When there is no any x-intercept with the curves, it means there is no any solution or there is no any roots, no zeros for the quadratic equation. However, it's possible to have the complex solution, which is not covered in your syllabus. But we can say there is no real solution for the curves that they do not touch the x-axis. In some situations, it's also possible to have a quadratic equation that cuts the x-axis at one single point only. So this is the x-intercept. That means there is one single solution for the quadratic equation because we have one single x-intercept. So you can say there can be three conditions for the solutions of quadratic equations. The first condition is it's possible to have two roots. Two roots exist. That means there are two solutions for the quadratic equation. That means when you say x equals to minus b plus minus the square root of b squared minus 4ac divided by 2a, as long as we have two roots, that means we need to consider the positive and negative side of this formula. As long as we have the positive and negative, we have two roots, it means the term inside the square root, which is called discriminant term, must be positive. It should be positive value in order to get the square root of the positive value and to get two roots. Therefore, in the first case or first condition, we can say that as long as there are two roots for the equation, then we can always apply this condition. You can say that b squared minus 4ac is always larger than 0, and it means it's positive. That's why we have two roots. When we have two roots, that means there should be two x-intercept points that the curve makes with the x-axis. And this condition is important, which is applied in other cases when there is a line meeting a curve at two distinct points. When they meet each other at 2 points, that means we can apply this condition in order to solve the question. And the second condition is no any roots. When there is no any roots, that means there is no solution, no real solution. When there is no solution, that means there is no x-intercept. If there is no x-intercept with a curve, it means this discriminant term inside the square root is negative. That's why we cannot get the square root value, because we cannot have a real value for the square root of negative numbers. So in this case, we can apply this condition. You can say that b squared minus 4ac is less than 0. It means it's negative. That's why we cannot have any solution or no any x-intercepts. The third condition is there can be one single root only. There is one root. When there is one root, it's actually like the root is repeated, because we know that for the quadratic equations, there should be at most two roots. If you look at the quadratic formula, you see that we have the positive and negative sides in the formula, that means we can have two roots at most. However, if there is one single root, what does it mean? That means the discriminant term is 0. That means b squared minus 4ac is 0. That's why we don't have this term here, and the only term remains is negative b over 2a. That means the only single root is negative b over 2a. So in this case, we always can apply this condition. You can say b squared minus 4ac equals to 0 if there is a line that's not meeting the curve at all. That means there is no any solution, then we need to apply this condition. And in case if a line meets a curve at just one single point, let's say at here, then you need to apply this condition in order to solve the question and to find the intercept point between the line and the curve. Okay, that's all for the quadratics and the main concepts we have covered here. Therefore, next we can move to consider solving the questions of the past papers one by one.